The purpose of this video is to demonstrate the use of the normal probability table. While for decades statistical software has made the use of these tables obsolete, they can be a useful tool for students, allowing them to, for example, solve problems using the normal distribution on tests and exams. If this applies to you, you may find it useful to work through the material in this video. Probabilities of continuous random variables, including random variables that have a normal distribution, are found from the areas under density curves. Here's an example, a normal distribution with a mean of 0, so the center or peak here is at 0, and a standard deviation of 1. Now, suppose we have a random variable, we'll call it z, and it has this distribution. If we want to find the probability that our random variable is greater than 1, say, we want the area under this density curve that is 1 or more. That is, the area under the curve to the right of 1. In this video, we're learning how to find this area from a normal probability table. Normal probability tables are for the standard normal distribution. That is, they are for the normal distribution that is centered at the mean of 0, that is mu is equal to 0, and that have a standard deviation of 1, that is sigma is equal to 1. In another video, we'll consider how to find probabilities for normal distributions with means and standard deviations that are other than 0 and 1. But for this video, we'll stick to the standard normal distribution. And throughout the video, we'll use z for a random variable that has a standard normal distribution, which we'll write as z tilde n bracket 0, 1. So that's a normal distribution for z with a mean of 0 and a standard deviation of 1. Normal probability tables can vary slightly. In this video, we're using the table from Open Intro Statistics. The URL is here. It's freely available on the web. The normal probability table covers 2 pages, one for negative values of z and one for positive z. Let's look first at the first page, the negative z page. And the first thing to notice is we see a diagram at the top. This diagram gives a hint to how to use the table. The area under the curve is shaded to the left. So all of the probabilities in the table give the probability of being less than the relevant value. Note that since this is a table for the standard normal distribution, the mean or center of the distribution again is 0. So on this page, all the values of z are in the left half of the graph of the density function. They're negative, so they're less than 0. The table has probabilities in the middle part of the table, and the corresponding values of z are in the column and row headings. As an example, suppose we want the probability that z is less than negative 1.82. We find the row corresponding to negative 1.8, and to get the second decimal place, we go to the column that begins 0.02, and then we can see from the corresponding probability in the table that the probability that z is less than negative 1.82 is 0.0344. The table only gives us 2 decimal places for z, so anytime you need to use a table, you'll have to round it to 2 decimal places. Suppose now that we want the probability that z is less than or equal to negative 1.82. Well, since z is a continuous random variable, the probability of it being any one particular number is 0. So the probability that z is less than or equal to negative 1.82 is the same as the probability that it's just less than negative 1.82, and so the answer again is 0.0344. Okay, so now suppose we wanted the probability that z is greater than negative 1.82. This would be the area to the right of negative 1.82. And since the total area under any density curve is 1, this must be 1 minus the probability that z is less than negative 1.82, which is 1 minus 0.0344, and that gives us 0.9656. Note that the smallest value in the table is negative 3.49. And the probability of being less than this value is very small, only 0.0002. For any value less than negative 3.49, the probability of being less than that is very small, so small that we can just approximate it by 0. So for example, if we wanted the probability of being less than negative 4, we would just say that it's 0 to many decimal places. The second page of the normal probability table works the same way, but for positive values of z. Since all the positive values of z are greater than our mean of 0, all of the probabilities in the second page are greater than 0.5. As the area less than a positive z covers more than half of the area under the curve. Otherwise, this page of the table works the same as the first page. Because of the symmetry of the normal distribution, we don't really need both pages. For example, the probability that z is less than negative 1.82 is the same as the probability that z is greater than positive 1.82. And we can verify this from the table. The probability that z is greater than 1.82 is 1 minus the probability that z is less than 1.82. That would be 1 minus 0.9656, and that gives us 0.0344 as before. Let's take this one step further. Suppose now we want the probability that z is between two values. That is, suppose, say, for some reason we wanted the probability that z was in between negative 3.12 and 0.14. To get this, we need to remember that the table only gives us probabilities of being less than a value. But the area under the density curve between negative 3.12 and 0.14 is the same as the area to the left of 0.14 minus the area to the left of negative 3.12. That is, the probability for a standard normal distribution of being in between negative 3.12 and 0.14 is the probability of being less than 0.14 minus the probability of being less than negative 3.12. And from the positive z page of the normal table, we get the probability that z is less than 0.14 is 0.5557. And then from the negative z page of the table, we get the probability that z is less than negative 3.12 is 0.0009. And that gives us our final result of 0.5548 for the probability of the region that we want. There is one more way to use the normal probability table. Suppose we know the probability and we want to find the corresponding value of z. So it's the reverse problem of what we've been doing. So for example, let's say we have the question, what's the value from the normal distribution that has probability less than it of 0.1? This probability is less than 1/2. So we know we need the negative z page of the table. Scanning through the probabilities on this page, the probability that is closest is 0.1003. And that corresponds to a value of negative 1.28. And so, to an accuracy of 2 decimal places, we know then that negative 1.28 is the value from a standard normal distribution such that the probability of being less than it is 0.1. One more example. Now suppose we wanted the value such that the probability of being greater than it is 0.05. For this value, the probability of being less than it would be 0.95. Scanning the positive z page of the table, 0.95 is halfway between two values. These two values correspond to a z of 1.64 and 1.65. We don't have a clear choice for the closer value, so we'll take the value of z right in the middle. So we estimate that 1.645 is the value from a standard normal distribution that has probability above it, or being greater than it, of 0.05. That is, the probability that z is greater than 1.645 is about 0.05. Many random variables have normal probability distributions, but very few naturally have standard normal probability distributions. But any normal random variable can be transformed to a standard normal random variable by first subtracting its mean and then dividing the result by its standard deviation. And as a result, we can then use the standard normal probability table to solve a wide variety of problems using normal distributions.